Hello everybody, welcome to our section 3.2 on the introduction to functions in our textbook. The first thing we need to do is we need to start off with some definitions if we're going to be starting to talk about functions, because one of the main things that you're going to be dealing with in the future when you get to your calculus courses is an analysis of functions. That's what calculus is all about. So we need to really know something about this. So let's talk about a definition of a function as a kind of relationship between a set of ordered pairs. Now, in your textbook, they define a relation to be any set of ordered pairs. However, a function is the kind of relationship in which no two ordered pairs have the same first coordinate. All right, so it looks like when we talk about what a function is, we're somehow getting a set of ordered pairs out of all of this. Now, they talk about words like domain and range. What does that mean? Well, in a set of ordered pairs, like the ones that you're looking at in the examples below, a domain is the set of all of the first coordinates of the ordered pairs, and the range is of a function is the set of all the second coordinates of the ordered pairs. So let's take a look at these two examples below. What are the domain and range of each of these? And is each of these relations actually a function, at least the way we've represented them here? Well, in the first case, the answer to that is, if we're looking for our domain, the domain is a set made up of all of the first coordinates. So we can make a listing set by the roster method right here and check them out. Our first 1, 2, 3, and 4, those are our first coordinates. That's what's going to make up our domain. So the set 1, 2, 3, and 4 makes up our domain. How about the range? The range is defined as the set of all the second coordinates in the ordered pair. So if we look at all our ordered pairs right here, we have 1, then we have 0, then we have 1 again, then we have 0. So it appears that our range really only consists of two numbers. In this case, that's 0 and 1. But does that make this a relation, or this kind of relation, a function? Well, let's take a look. It says that in which no two ordered pairs have the same first coordinate. The first coordinate is not repeated. Well, 1 goes with 1, 2 goes with 0, 3 goes with 1, and 4 goes with 0 again. None of the first coordinates are repeated. So in this case, we're going to say that, yes, this is a function. How about the second one? Well, let's take a look. So we look for our domain. In this case, our domain looks to consist of the numbers 1, that's definitely there, 2, there's 2 again, but we'll come back to that, 3, and 4. Well, this is just like the last function. It has the same domain, right? The range, well, it looks like the range right here goes, if we look at our second coordinates here, 2, 3, 5, separate each of those elements with a comma, 7, 9, and 11. Uh-oh. Well, you see there's kind of a mismatch here. There's only 4 elements in the domain. There's 1, 2, 3, 4, 5, 6 elements in the range. And not only that, we see that each of these values right here are repeated, right? The 2's and the 3's have repeated themselves in this case. That can't be, right? No two ordered pairs have the same first coordinate. Well, we look like we have 2 sets of ordered pairs that have the same first coordinate, so we're going to have to conclude that this is not a function. People look at ordered pairs like this and get the idea, well, all right, that seems to make sense. What do we mean by ordered pairs? But I think an analogy is in order, and I really like this next analogy. So let me lay it on you here. Let's say you go to a store. This is an analogy here of going to the grocery store, and you pay $1.50 for a box of rice-a-roni. That means, of course, if you buy you buy 2 boxes, you're going to be paying $3. For 3 boxes, $4.50, and so on. Is that a function? Well, yeah, sure. Every time you buy a box, or let's say you don't even buy a box, right, you pay one price. So each set here, each value, 1, 2, 3, right, we could say 4 would cost us $6 and so on. That is a function. It's a one-to-one match for each number of boxes with the number of prices. Yeah, that is a function. So the answer here is yes, absolutely. This is a function. How about the next one, though? Let's see. At another store in town, I can buy 2 boxes of rice-a-roni for 1, but only if I buy 2 at a time. So they've got a 2-for-1 special. Does that change things? Well, let's see. The price is the same for a single box as above. So that means if I buy 0, of course, I'm paying $0. But if I buy 1 box, I pay $1.50. But if it's a 2-for-1 sale and I have to buy 2 at a time, that means if I buy 2 boxes, I'll pay $1.50. Oh, pretty good. Good deal, right? 3 for $3. That would mean 4 for $3 because I could get 2 for 1, 2 for 1 again, right? And so on down the line. Now, does this count as a function? Well, again, the answer to that one would have to be yes. And the reason why we're going to say that it's a yes is because if we look at the number of boxes, right, we only use each box once. Right? So we say 1 box, or 2 box, or 3 box, or 4 box. Each number of boxes that we buy is matched with only 1. Now, it doesn't matter that that second number is repeated. It counts, right? This second number can be repeated. It's the first number that's important to us if it's a function. All right, so I decide to go to a third store. This time, the owner has a different pricing screen. He says, well, okay, yeah, you're buying 0 boxes, you're paying $0, clearly. But if you buy 1 box, you're paying $1.50, but maybe if you buy 1 box, he wants to charge you $3, right? Seems a little crooked right here, right? Two boxes, well, let's say you pay $3, but 3 boxes is going to charge you $4.50, right? Well, this is not fair at all, right? How can you be charged for 1 box 2 different prices, right? Does it depend on who you are? That doesn't work, right? So in this case, this cannot be a function, right? So emphatically no. And not only that, I think we should call the Better Business Bureau on this particular merchant for charging 2 different prices for the same thing, right? Okay, so that's an introduction to functions here.